So we're going to play around with summary statistics. In particular, I wanted to talk about standard deviation. So summary statistics and stat key gives us a bunch. So we could put this data into stat key and get them there. That's sometimes a little quicker if you get the data incorrectly. Otherwise, you got to type some stuff out. So usually we label stuff. So I'm going to label this one count. And then I think, what else do I want to put here? Here and the standard deviation, STD, abbreviation, EV. And how about the 5-number summary, which is the min, Q1, the median, Q3, the max. From that, we can get the range of the data and the IQR. And then we can also calculate the IQR outliers. So we have, yo, Elsie, hello. Anyone else just join? So I'm just doing a review of some stuff from last time, and I'm going to pay a little more attention to standard deviation here in just a moment. The data set that I'm playing with, if you wanted to play 2, I chatted out the address to it. Oh, what happened to the chat box? So if you find your chat button and click it, there's a URL there. You could copy and paste that into your browser, and then you can either download this or make a copy of it. Let's see, what else was I going to do here? Oh, I was going to do what they call the low fence, the upper or high fence. A little wider. There's the majority of the summary statistics. I think so. So to count the numbers, it's usually safest to ask the computer to do so. So there is a function called count. There's a bunch of different count functions. And then just select your data by highlighting, or if you click at the top, Control Shift down arrow finds the end of the list. Good job. Computer says there are 203 countries in my list. Mean is average, also called arithmetic average, and like the numbers. If there's nothing else in the column besides the numbers and some titles, you can usually just select the whole column when you're doing these. For standard deviation, there's a whole bunch of them. STDEV is a fine one to use, or STDEV.S. For sample. This is kind of a population because it is all of the countries, but I'm going to stick with the sample version of standard deviation, and they do give slightly different results. And I'm going to highlight the specific numbers. So, and again, I'll get to what standard deviation is in a moment. And then the other ones equals min, data, quartile, and that is, if I can spell, Sheets has a quartile function. Excel got rid of it. They have a quartile inclusive and exclusive. You want the inclusive one. Highlight all the data, and then which quartile do you want? And I want the first one for now. And if you copy and pasted this in the stat key will give you most of these in one shot, which is kind of nice. Data, quartile 2, data, make sure you get all of the data. And this is quartile number 3, so I do a comma 3. Max, which is kind of redundant because I have them in order. But, oops, what did I do wrong? There we go. All right, and then the range is just the difference between the max and the min, so just a quick subtraction. Pull that up a little. The IQR, interquartile range, is the distance between Q3 and Q1, and I'll draw that out in a sec. So equals Q3 minus Q1, and then I'll come back to the fences in just a second. So let's talk about standard deviation. To talk about that, I need to get a histogram to help explain it. So let's grab all of the data and ask Google for a quick histogram. Okay, and it said, sure, I can make a histogram. And it selected 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 groups for my data. And it looks like the group width is 1.18, roughly, approximately. If you don't like the distribution of columns that you got when you do the quick histogram builder, and this is, I'm skipping over the frequency table for now, then you would go to customize histogram and change the bucket size. So maybe I'm going to try a bucket size of 2. And then it goes from 1 to 3, 3 to 5, 5 to 7, and so on. And it's showing enough digits in the decimal to accommodate the data. And so the data has 1 decimal place, it's showing 2, an extra place, which is not uncommon. All right, so I think I like that one a little bit better. And I am going to copy that into my notebook to explain standard deviation. And current page is fine. Where'd you go? All right, okay, so there's that. Next, I need to know what the standard deviation is. It looks like it put that at the very bottom. That's okay. All right, so we have a mean of about 8. So that's too many digits. Let's decrease those a bit. Let's see, the data has 1 decimal. Usually when we calculate summary statistics, if there's a lot of digits, we usually do 1 more than what the data has. So this has tenths, so I'm going to go to hundredths. So let's copy that information. And all right, so we have a mean of 8-ish and a standard deviation of about 3. So I'm going to mark those off here. 8 would be about here. So that's what we call X bar. X with a bar over it is the mean. And our mean is approximately 8. Standard deviation is average spread from the mean. So just to show you what deviation is, if I made an extra column here, let's call it deviation. And then I take the United Emirates number of 1, and I subtract from it the value of the mean, which I'm just going to call 8 for simplicity. And let's make that prettier. This tells me that the United States Emirates is 7 below average. So deviation just means how far are you from the middle. And if I take that formula, and again, what I did was I said, all right, to find the deviation, which means distance from middle, I just say equals whatever the data number is, subtract the mean. Okay. So all these countries here are below average, which for death rate is a good thing. So I'm just going to fill that formula all the way down to the bottom. Oh, there we go. So other countries are above average. So for example, Estonia here has a death rate of 11.6 people per 1,000 per year, and they are 3.6 above average. So some countries are above average, some countries are below average, some countries are right at the average. Okay? So in any given data set, there's a middle. Sometimes the middle is average, sometimes it's the median. We can use either or both. And then most numbers in the data set are not average. They're above average or below average. Every once in a while, the average is one of the numbers in the data set, maybe even more than one, like the 8 back here. But there's no guarantee that the value of the average is actually going to be in your data set. So what this shows me is the distance from the middle of each of those numbers. If we were to try and average those deviations, we'd run into a bit of a problem. So remember what average means. It means two different things. It means add up the numbers and divide by how many. But the other thing it means is it's about sharing. So if we were somehow to be able to transfer some of the deaths from Sierra Leone over to the United Emirates, and then some of the lack of death from Qatar, take it from a country that has a lot more deaths. So the countries with a lot of deaths, they drop, and the countries with very few deaths, they rise. If every country had 8 deaths, then we would have the same number of deaths worldwide. So average is about sharing. And let's see, we got more people who's joined us. Kayla, welcome, Kayla. So again, distance from center, and average is, the weighted center. So if I try to add up all these deviations, this is kind of crazy, with a sum, and grab all of them, except the title. Oh, crap. There we go. Enter. Ooh, what went wrong there? Oh, it's because I didn't use the right average. Let's try that again. Let's use the actual average equals death rate minus the actual average. Fix that in row 4. Okay. So using now the real average instead of my estimate. The sum of the deviations is 0 because of the way average is calculated in the middle. Because I could replace all of these numbers with 8.07 deaths per thousand, and I would still have the total number of deaths, same total number of deaths worldwide. So one problem with deviation is some countries or some numbers are above, some numbers are below, but on average, they balance out to the middle. Average is the middle in a weight distribution. So if it adds up to 0, how do I average it when I try to add them? Well, the trick people came up with is what they do, and they show this in the book. They take all these numbers and they square them. That gets rid of the negative. Then they average the squares, and then they take the square root. And that gives us a measure of average spread. Another way to do it is to just strip the sign. That's called mean absolute deviation. And the book goes over that, but nobody does it in the real world. It's just for educational purposes, so I'm not even going to cover it. So the process that the book goes over of making a table to calculate the standard deviation, don't ever do that. It's awkward, it's challenging, there's no need to do it because we have calculators that make the calculation for us. And all we need to know is that standard deviation is an average measure of spread for a particular data set. And every data set will have a different spread. It's just data is different. So let's go to my whiteboard and sketch out what's happening. So I'm going to say the standard deviation is about 3. So again, standard deviation is an average deviation. Deviation is distance from the mean. So again, standard deviation is an average. There's many ways to do it. This is the best one though. Of spread from the mean. Okay, so to calculate standard deviation, we have to subtract the mean from every number in the list, and then square them, add them up, divide by how many, and take the square root. You never have to do that by hand. We just push a button. So one average spread to the right would be 8 plus 3, which would be 11. So at 11 here, I would call that plus 1 standard deviation, and usually the letter S is used for standard deviation. So mean is an X with a bar over it, and standard deviation is usually abbreviated with just a lowercase letter s for a sample. If I add another 3 on, so 8 plus 3 is 11, 11 plus 3 is 14, that would put me right here. I would abbreviate that as plus 2 standard deviations. So I'm 2 standard deviations to the right of the mean. To find that number right there, I would take x bar and add 2 times the standard deviation. So in this case, that would be about 8 plus 2 times 3. 8 plus 6 on a good day is 14, which is where I'm marking right there. If I did it one more time, 14 plus 3 is 17. This number right here would be plus 3 standard deviations to the right of the mean. Okay, and the plus 1s plus 2s plus 3s is an abbreviation for x bar plus 2s, or x bar plus 3s. We can go the other way too, because some numbers are below average. In this case, below average is better. We want to have fewer deaths, usually. We like to preserve life. So 8 minus 3 would be 5. So that would be 1 standard deviation to the left, or minus 1s. Subtract 3 again, and I get 2 right here. So that would be minus 2 standard deviations. And often we look 3 to the right and 3 to the left. So if we subtracted from 2, another 3 from the standard deviation, that's going to take us over here at -1, which would be 3 standard deviations to the left of the mean. And in this case, sometimes negative numbers are meaningful, like with temperature and debt of money. But in this case, what does negative deaths mean, right? That's zombie land. So people are coming back from the dead. We don't currently do that. So this number, 3 standard deviations to the right, although we can calculate it, it turns out to be meaningless because it's in a range of values that doesn't mean anything given what the variables mean here. And here we're talking about death rates. What this shows me is that within 1 standard deviation on each side, that means I'm looking at countries who have a death rate of 5 deaths per thousand up to 11 deaths per thousand. If we look 2 standard deviations on each side, then that would be from 2 deaths per thousand up to 14 deaths per thousand. So let's see what that looks like on our spreadsheet. Desktop. So I didn't have to calculate these deviations. I just did it as an educational thing. I really don't need them. Standard deviation is just a matter of using the stdevs feature. So again, if you tuned in late, that would be equals, start typing st for standard deviation, maybe even throw the d in there to narrow it down. And we want the .s for standard deviation of a sample. There's also standard deviation of a population. There's a couple of versions of those. Rarely do we have a whole population. Usually we just have samples to work with. And so all you do is highlight the numbers with that function to get an answer. And so Excel should give exactly the same value. Okay, so what I wanted to do is I wanted to count countries that are within 2 standard deviations of the mean. Standard deviations. And so that's what I was drawing in the picture here. So I made a calculation and a mark on the histogram. And what you can see is that almost all of the countries live in between 2 deaths per thousand and 14 deaths per thousand. There might be a couple less than 2, and there's a few that are greater than 14, but most of them live in there. The book makes a claim near the end of section 2 that at least 75% of the data in most data sets will be within 2 standard deviations. And there's another claim the book makes later that usually it's going to be around 95%. So let's see what we got here. So then if I wanted 2s, oops, I'm not typing, go 2s below versus 2s above, we calculated that was approximately 2 deaths per thousand versus 14 deaths per thousand. And so let's see, the first country who's above 2 is Bahrain, and then they're going in order. So I'm just going to highlight all the numbers up till I get to 14. Getting there, okay. So then right up to 14, but not 14.1 is too many. And on, oops, come here, get out of the way, please. Sorry, my Zoom toolbars are in my way, and I'm trying to grab it and move it. Why won't you move? There you go. At the bottom of Google Sheets or in the bottom of Excel, when you highlight a group of numbers, it'll give you a quick preview there, and it said the numbers add up to 1,400. I was curious about the count. So I just highlighted 188 numbers, and I was looking again for countries with death rates from 2 up to 14. So that count of what I highlighted is important. So the count for the countries between 2 and 14 deaths per 1,000 is 188. And so if I turn that count into a percent, I would have to take the 188 and divide by the 203 countries I have in my data set here, and that comes out to about 93%. Okay. So it's definitely above 75. It's closer to 95, like one of the other claims in the book. And when I look at the graph of this data, I'm going to go way down here, it's got a nice symmetric shape to it. It's a little bit skewed to the right. And again, a skew in a histogram is the tail. The book really doesn't talk about that, but when we talk about skewed data, if there's some numbers that are hanging out to the right, we say it's skewed right. If there's a few numbers hanging out to the left, away from the pack. And so I would say the pack is like these 4 columns right there. So again, 93 roughly % of the data lies within 2 standard deviations. Often within 1 standard deviation, there's going to be like 60 to 70%. So we could check that count too. So within 1 standard deviation of the mean, that was what in our calculations? From 5 to 11. So remember, 8 is the middle, 1 standard deviation below average is 5, and 1 standard deviation above average is 11. So I want to see how many countries have a death rate between 5 and 11. So 5.1 over to 11. 11.1 is above, and the computer counts 139 numbers that I just highlighted. There is a formula to make that count, but it's wicked complicated. I'm not going to go over that. So I find that count to be, what was it, 139? Eek, I forgot. Remind me. Nobody wants to remind me, or nobody noticed. You guys awake there? 11. Yep, 139. So 139 countries out of 203 gives me about 68%, which is a pretty typical number we'll see. But every data set's different. There is no standard rule about what percent we expect to see within 1 standard deviation, but there is some theory behind 2 standard deviations. And it's pretty unusual to see anything less than 75% of the data within 2 standard deviations. It's more typical to see like 95% of the data within 2 standard deviations. But there's all different kinds of data out there. So when we're trying to describe a data set to someone, right, just showing them the numbers is useless. Charts help. So let me move this chart. Can I cut and paste you? Let's try. Don't know if that works. Yeah, cool. So in order to describe data sets to people, we have to do things like give the summary statistics to say, hey, on average, most countries in the world have about 8 deaths per 1,000. If we look for the middle number, when they're in order, it's more like 7.5%. And notice the mean is bigger than the median here. Mean and median are 2 measures of center. And usually if there's a right tail, that pulls the mean away from the median. So that doesn't always happen, but it typically happens. So the mean is a little higher because of those few rare countries that have very high death rates compared to the rest of the crew. So what we should find is that numbers in this right or these right columns are probably outliers. So we're going to take a look at that next, calculating outliers. And feel free to ask questions. Anyone else joined us? Since Kayla, nope. Okay, so let's take a look at a box plot. And do I dare draw this? It's kind of a pain to draw by hand. I could draw it on my notebook. I'll do the StatKey version. Okay, so to have StatKey make a box plot for you, which is one thing I want you to do for, let's see what the heading to for this. I think I asked that. Let's see. Home, activity 2. Make a box plot. I just say make a box plot. Okay, I meant to say more than that. All right, so here's what I would do with a box plot. StatKey is a good box plot generator, and I linked to StatKey back on that videos and more page. So if you go to videos and more, there's a link down here to StatKey. And we are playing with one variable, one quantitative variable. Quantitative means number, as opposed to categorical, which would be things like yes, no, male, female, eye-colored, ethnicity, where we have actual numbers, so it's quantitative. To have StatKey generate a box plot for your numbers, right now it's using mammal longevity, and there's a bunch of other ones here. All I do is go to edit data, highlight and delete their data, and then paste mine in, and then double check about these check boxes. So this says there's a first column that identifies each number, and I do not have a first column that identifies each number. And this says data has a header row. Did I copy in a header row? I did, so I'm gonna leave that checked. So make sure you double check whether these boxes are true or not, and check or uncheck them as necessary, and then hit OK, and then box plot. So here they are plotting the minimum, Q3, the median, Q1, the median, Q3, and then the max is over here. So it draws the box plot a little different than your book does. Those numbers for min, Q1, median, Q3, and the max are also listed in this summary table. So one nice thing about StatKey is it gives you a histogram, a box plot, and the summary statistics just by uploading your data. And although there is an upload file option, that's a little trickier. It's easier to go to edit data, delete their stuff, and paste in your data. Important thing here, the data has to be one number per line, nothing else. Otherwise, StatKey freaks out on you, gives you an error message. So I want the box plot. You can't copy and paste the box plot. It doesn't work. They don't have that feature. So you have to do a screenshot. And if you're in Windows, screenshots use the snipping tool. If you're on a Chromebook, I used to know how to do it on a Chromebook, but I forgot. And on a Mac, it is Command-Shift-4. It's my recollection. I want a rectangular snip. And I don't need the top of the box, but I do need the top of the graph. And I also need the numbers at the bottom so I can line things up. And usually what's helpful is you want to line up the numbers in the graph here with the numbers on your histogram. So next you got to save that screenshot. And sure, I'll put it in downloads, give it a name that you'll remember. Oh, come on, fine. Let's see. Death rates. And save. And then to put it in your spreadsheet, you just go to Insert Image. In Google Sheets, it's image over cells. Otherwise, it tries to cram it into a little cell. Browse. Find that file, ABCD, death rates. And it throws it in, usually near the top. There it is, and it comes in pretty big because of the resolution of my screen. So what I want to next do is try to line it up with my histogram here. Come on, scroll, please. And so let's see, this one has 5, and there's a 5. It's got a 10. 10 would be in between. So grab the corners to resize and reposition it, trying to get some like numbers to line up. So I got the 5s to line up. But over here, whoa, that was weird. Let's see, there's 15. So if I can get the 5 to line up there and the 15 to line up there, and again, I recommend using the corners to do so. Let's try that. 5, almost, just a wee bit smaller. How's that? 5 and 15, pretty damn close. All right, and then once you get that lined up, then just move it either above or below. And I'm going to go for below, and I'm going to zoom out so we can see them together. So what I should see is that anywhere there are tall stacks, I should see a narrow part of the box plot. And anywhere there are shorter stacks, I should see longer parts of the box plot. And remember, what does a box plot do? The main divisions are Q1, the median, and Q3. Q1 is a position in the data set so that 25% of the numbers are less than that. So if we just double check that theory here, Q1 is 5.95. So if I look for, there's a 5.9. If I count how many numbers are below 5.95, my computer says 51 numbers are below. And then if I ask the computer, what is 51 divided by 203, the computer said, hey, it's about 25%. Okay. Is it going to be exact? The answer is no, because there aren't exactly 100 numbers in the list. Quartiles are also percentiles. Percent means out of 100. So again, basically what the quartiles do, and there are 5 quartiles, the min, Q1, the median, Q3, and the max. So the min, by the way, is also Q0, so that 0% of the data is below that. The median would be Q2, so 2/4 or 50% is below that. And the max is also referred to as Q4, quartile 4. 4/4 of the data, 100% of the data is at or below the max. Okay, so just different graphical representations of the data. And I just want to re-emphasize the ideas about the quartiles. So let's zoom out and grab that so I can scribble on it. Not enough. Screenshot this stuff. Should be good. And blow it up. So again, what does a box plot tell me? Each of the 5 numbers split this up into 4 chunks. So we make a cut here. This cut is Q1. We make a cut here. That's the median, usually an M. We make another cut on the number line there. That is Q3. And then way at the end here is the max. And way at the end here is the min. So if you ever draw one of these by hand, which you could for this, you don't have to use a box plot generator. You would make a nice number line, and then on your number line, you would mark off the min, Q1, the median, Q3, and the max. You draw a box from Q1 to Q3 and whiskers out to the min and then out to the max. And so StatKey claims that these 3 points are outliers. That's why they're starred. So we're going to calculate that next. But just a reminder, 25% of my data lives between the min and Q1. So they're kind of, the first 25% of numbers are kind of spread out there. The next 25%, they're pretty tightly packed together between, what were those numbers again? Let's grab those. Show desktop. And we want that 5-number summary. Zoom, screenshot, current page. Oops, come on. Oh, no. Oh, where'd you go? Darn it. Sorry, technical difficulties. There you are. Go over here, please. You guys go. I totally messed this up. Right there-ish. Okay, close enough. So from 5.95 Q1 to the median of 7.5, that's another 25% of the data. Lives in that little tiny range. Little more room in the third quarter. That's 25% of the data too. And then this last big long stretch has 25% of the data. So there's about 51 of the countries here, 51 of the countries live in this box, another 51 live in that box, and another 51-ish live in this whole stretched out region there. Narrow regions in a Boxplot relate to tall stacks in a histogram. Short stacks in a histogram lead to wide areas of a Boxplot. All right, so calculating outliers. That's the next big thing. New page. And the book mentions two different techniques. The first one they go over is called the IRQ rule. And what we do is we calculate what I call a lower fence and what we're doing is we're fencing in more common values in a data set. And the lower fence is always Q1 minus 1.5 times whatever the IQR is. And then the upper fence for usual values is Q1, Q3, I lied, minus 1.5 times the IQR. So we'll calculate those in a sec. The other method the book mentions is the 2 standard deviation rule. So there, the lower value would be the average minus 2 standard deviations, and the upper value would be the average plus 2 standard deviations. And that's because there's statistical theory that between 75 and 99% of data lives within 2 standard deviations in most data sets. So anything outside of that is unusual compared to the herd kind of thing. Like for temperature of humans, we expect the average human body temperature, like we say it's 98.6, it's actually on average a little lower than that. But if we use the 2 standard deviation rule, then human body temperature is usually somewhere with an average low of about, let's see, 97-ish and a high of about 100. So if your body temperature is between 97 and 100, that's considered normal. Most people are in there. Not everybody is 98.6, and your temperature varies throughout the day, depending on what you do and a whole bunch of other stuff. If somebody has a temperature below 97 degrees, that's weird for a human body. Something's wrong. And if somebody has a temperature above 100 degrees, that's weird also. Something might be wrong. So that's why we use temperature to kind of indicate, is there some kind of infection that's troubling an individual? Because we have lots of evidence that almost every human body is somewhere between these two temperatures in degrees Fahrenheit. All right, so applying the IQR rule for our data, let's go back a page here. So what we do is the IQR is the interquartile range. That's the distance from here all the way to there. So IQR is the width of this box. So for us, the width would be 9.7 minus 5.95. So let's go put that in the spreadsheet. And oops, looks like I already did that. So 9.7 minus 5.95 is 3.75. Then we expand that number by 50% because the formula for outliers says take 1.5 times the IQR. So again, visually what's happening is we take the width of the box, we make it 50% bigger, and then we take that new width and we add it to the end of Q3, and we take it away from the Q1 and see what happens. So I'm just going to write that in underneath. What is 1.5 times the IQR equals 1.5 times the number above? I get it's about 5.6-ish. So if I look at my picture back here, so I'm at 9.7. If I add 5.6-ish, that's going to throw me right here. So this is what we call the upper fence. And if I take the IQR and I subtract that 5.6-ish, that's going to throw me, is that what it was? Show 5.6-ish, yep. That's going to throw me somewhere around right here-ish. So that would be the lower fence. And where stat key draws the box plot and anything above or below the fences, it puts asterisks as the points. I usually do a slightly different technique where I mark the fences with an asterisk, and my whisker goes all the way out to the max, which is the way your book does it too. So back to the spreadsheet. So the lower fence is always the value of Q1 minus this expanded IQR. And notice I already multiplied the 1.5 for that number. So that ends up being about 0.3. My lowest number was 1, which is above the fence. So the United Arab Emirates, who had a death rate of 1 per 1,000 per year, is within reasonable tolerance of the rest of the countries in the world. The high fence is always going to be Q3 plus that expanded box, which is the 5.6 number here. So again, this number right here was Q1 minus 1.5 times the IQR. This upper one is always Q3 plus 1.5 times the IQR. And so these fences give us one way to look at outliers. So since there were several countries above 15.3, if we scroll down to see them, we have 3 numbers. Let's highlight those in pink. Okay. These are outside expected or usual range according to the IQR rule. And then if I apply the 2 standard deviation rule for outliers, so the fences are one way to talk about outliers. So if I look at, let's call it bar x, because I can't do x bar, minus 2 standard deviations versus bar x plus 2 standard deviations. So start with the mean and then take away 2 times the standard deviation. So this says any country that has a death rate that's lower than 1.8 is unusual compared to the rest of the group. Now the IQR rule and the standard deviation rule, they don't usually match, and that's no big deal. There's just different ways to talk about this stuff. And then if I take the mean and I add 2 times the standard deviation, I get 14.3. So any country above 14.3 would be an outlier. So 1.8, that would be these 2 countries are unusually low compared to the rest of the crew. Let's highlight those in greenish blue. So these are unusually low. And then anything, according to the 2 standard deviation rule, anything above 14.34 is unusually high. 14.34. So that would be all of these guys here from 14.4 on up. And I'm going to put the highlight in a different spot. I think I used that color. So these guys are unusually high. That was using the 2STD rule. So, man, we just did a heck of a lot of descriptive statistics. So this is, I did way more than I asked you to do for activity 7.2 here. I kind of went over everything again from section 7.2. So you might want to reread some of that stuff. So I wanted you to do the standard summary statistics, which are the count, the mean, the standard deviation, and then the 5-number summary and the range. Make at least one histogram and make a box plot. Now here I asked for a histogram. I didn't ask for a frequency table, and that's okay. So either Google or Excel can do a quick histogram by just highlighting the data. So I'll just show that again. If you want to make a quick histogram like this, highlight all of your numbers and then say, Google, give me a chart. And Google says, hey, here's a histogram. If you like it, or it's good enough for you, cool. If you don't like the way it drew those bars and the numbers at the bottom, you could go pick nicer numbers by customizing the histogram and picking a bucket size. So here I can see the bucket size is 1 point something. I could say, let's try a bucket size of 1.5. So Google will offer suggestions, and they always offer the same suggestions, so that's not always a good thing. So I could try 1.5. So it's going to go from 1 to 2.5, 2.5 to 4, 4 to 5.5. Yeah, that's not bad. I liked 2. Google picks the starting point for you. If you don't like what it picked, then you would have to go down to the horizontal axis and set a minimum number. Like maybe I want to start at 0. So now it'll go from 0 to 2, 2 to 4, 4 to 6. And I get a slightly different looking histogram. And Office 365 isn't as full-featured as this, but regular Office is. Does anybody here want to see a histogram in Office again? Is silence a no? I'm okay with that. Okay, silence is a no. So let's get rid of the extra one. So again, the summary statistics I want from you are this group right here. And I want at least one histogram, and I want a box plot. And you can either use the Hermiston data or use the Pendleton data. So you'll either use sheet 1 to do Pendleton or sheet 2 and do Hermiston. And you can have all of your work just sitting over here to the right of those values. And you can use Google Sheets or you can use Excel, whatever your preference. All right, it is 4 o'clock. That's a good stopping point. If anybody wants another session with me this week, just let me know. I'll be glad to schedule a Zoom session for your group or for you individually. If you're not sure who is in your group, let's see, how do you see that? You go to people, and then I think it's got groups over here. Actually, let me get my fake student here. People, leave please. And then groups, and you should be able to see the groups that were assigned for our class. And the lock means I'm not in that group. The unlock one means I'm in that group right there. So those are the group members. The group members aren't for assignment 7.2. They are for the follow-up to 7.2, where we compare Pendleton to Hermiston based on the graphs and the summary statistics, trying to decide if housing prices in Pendleton are much different than housing prices in Hermiston, and then whatever evidence you have for that. And most likely it's not going to be like a yes or no answer. It's going to be a little complicated. So you guys need to discuss that amongst yourselves. And then only one of you needs to do the submission. So you guys decide who has the better spreadsheet to submit for your group. All right, that's it for now. Give me a call or send me a message if you have any questions. Remember, you can message me from the other homework set, those practice problems. In the homework, every question should have a message instructor at the bottom. So if one of these was giving you fits, then message me and I will help you out. And then my responses will show up in this little message icon over here. You'll get a little red #1 message or something like that there. So the messages about this homework are different than the inbox in Canvas. All right, take care. Have good math. Have good math. Do good math. And I hope your life is going reasonably well in this crazy isolation. Do things to take care of yourself, and I will see you in the near future. Bye-bye.